Newly released image of 3I Atlas confirms it's not a comet.
The James Webb Space Telescope just blinked, and what it saw has never happened before. It's a tale that sounds like science fiction, but the data, my friends, the data is screaming something truly extraordinary. We're talking about 3I Atlas, a ghostly interstellar comet that's not just passing through, it's practically spraying chemistry so reactive, so dynamic, it looks, well, dare I say it, metabolic. The numbers, they're not just rising, they're climbing. Every single hour, its plume is shifting, turning this impossible emerald green, and its trajectory, it's bending, and not just by the gentle tug of gravity alone. We've got activity inside that 4-kilometer snowball, activity that's rising like a heartbeat. And it begs the question, doesn't it? Is the universe about to hand us our first true "it's alive" moment? Or are we witnessing a new, mind-bending form of cosmic chemistry that will redefine everything we thought we knew about comets? On 1 July 2025, the Atlas survey in Chile, a sharp eye on our cosmic neighborhood, flagged a fuzzy dot racing in from the constellation Cepheus. And let me tell you, this wasn't just any dot. Within 48 hours, the orbital mechanics screamed Interstellar. It's only the third visitor ever confirmed from outside our own solar system. Imagine that, an object from another star system zipping through our cosmic backyard at an impossible speed. Its hyperbolic path will sling it around the sun at a blistering 68 kilometers per second, a one-way trip, never to return. But before it makes its grand exit, our incredible James Webb Space Telescope, always ready for a show, swiveled on 6th August, training its super-sensitive NR-SPEC instrument right on that tiny nucleus. Now, what did scientists expect? A standard mix of water and carbon monoxide, the usual cometary suspects. What they got instead? A chemical storm. We're talking 10 times more carbon dioxide ice than water, which is highly unusual for comets in our solar system. Then there's nickel vapor without a trace of iron, a complete anomaly, and cyanide jets surging brighter every single day, even turning the comet's coma a dramatic green. Normal comets, my friends, they simply don't behave like chemistry labs on overdrive. This thing is too bright, too steady, and too self-contained to fit any familiar category. The usual comet rules just don't apply. Clearly, something is driving that frenzy from within, and it's unlike anything we've seen. Here is where the story truly tilts, where the data starts to whisper something truly profound. While measuring infrared heat, the JWST didn't just find heat. It recorded a gentle, yet unmistakable 3.7-hour oscillation in the outgassing rate, up, down, up, down. This pulse was locked to the comet's rotation, yes, but it was also slowly, steadily gaining amplitude. Picture a kettle whistling louder, more insistently each time it spins. But here's the kicker, no purely passive ice should do that. Solar heating simply can't ramp up that fast, that precisely. The emission was steady, holding at levels 3 times higher than any model predicted for an object this size and distance, with no tail, no flicker, just a fixed, unwavering beacon. Planetary scientists, they ran the numbers again and again. The only matching models either invoke buried pressurized pockets seal bursting in sequence, which itself is pretty wild, or, and this is where it gets interesting, a chain reaction that keeps feeding itself. In biology, we call that positive feedback. In space jargon, it's simply anomalous activity. And then the shocker. A researcher quietly scribbled the word metabolism in a margin note and immediately crossed it out. But you know how these things go. The note leaked, headlines followed, and the public, naturally, latched onto the single most explosive interpretation, life. This convergence of a thermal heartbeat, so regular, so persistent, is what truly makes us scratch our heads and ask, what exactly are we looking at? So let's play the ultimate thought experiment, shall we? What if What if microbes did ride this comet? They'd need some seriously robust antifreeze chemistry to survive the void. And guess what? CO2 and cyanide, the very chemicals we're seeing in abundance, are excellent candidates. These hypothetical microbes could melt pockets, exhale gas, and as the comet's rotation exposes new ice to sunlight, they could repeat the cycle, producing that rhythmic brightness surge, that heartbeat. We already have Earth extremophiles that happily snack on perchlorates at a chilling -40 degrees Celsius, so a cyanide cocktail isn't necessarily a deal breaker for life as we know it. But here's the catch, the massive, undeniable catch: scale. To push a 4-kilometer body, to generate that kind of sustained activity, you'd need trillions of cells, all coordinating, all working in concert. Earth's polar algae blooms can flip colors overnight, but they have the luxury of liquid water. On 3I Atlas, gravity is weaker than a gentle sneeze. Any gas escapes instantly. Could a biofilm, a coordinated network of these hypothetical organisms, cling long enough, work efficiently enough to keep this engine running? Honestly, no Earth analog exists for something like that. It challenges our very understanding of biological limits. Yet the maddening thing is, the maths, the cold hard numbers, they still refuse to rule it out. There is, however, no credible scientific evidence or report that the James Webb Space Telescope has detected something alive inside the interstellar comet 3I Atlas. Now, before we collectively shout aliens from the rooftops, sober physics, thankfully, offers us several escape hatches, several non-biological explanations. First, we have exotic ice phase changes. Imagine carbon dioxide clathrate, a sort of icy cage exploding when sunlight hits it. If the nucleus is porous, pressure could build in chambers until the crust cracks, leading to rhythmic outbursts without any biology. Second, there's electrostatic lofting. Ultraviolet light charges dust grains, levitating them until they short-circuit in many discharges, again pulsing the coma brightness. And third, fragment shedding. A slowly splitting core exposes fresh volatiles, boosting emissions on a timer. All three of these elegant solutions could fit the JWST spectra and that intriguing 3.7-hour cadence. And honestly, Occam's razor, that principle of choosing the simplest explanation, would absolutely prefer them. But here's the problem. The truly confounding problem is that each of these natural processes predicts that the signal should eventually fade or at least drift. Yet what JWST is showing us is the exact opposite. It's getting stronger, more regular, more insistent. That's why even the most hardened skeptics, the ones who usually have an explanation for everything, are admitting we've never seen this template before. None of the 4 leading models, outgassing jets, radiogenic heating, dust scattering, or mass estimate errors, could explain the full chain of anomalies we're observing.
But wait, there's more. Hidden in the astrometric data, the precise measurements of its position, is a subtler yet equally profound anomaly. Between mid-August and early September, 3I Atlas deviated from its predicted gravity-only track by a staggering 300 kilometers. Now, on solar system scales, that's tiny, almost imperceptible. But for a celestial body, it is absolutely unmistakable. Comets, we know, can rocket off course via jetting as gases escape and provide a tiny thrust. But here's the kicker. The vector, the direction of this extra push is all wrong for a simple sunward jet. Instead, this extra push aligns precisely with the comet's rotation pole, almost as if thrust is emerging along the spin axis itself. Again, we're left with 2 mind-bending possibilities. Either a deep, super volatile vent has aligned perfectly by sheer cosmic chance, or something under the crust is actively steering, using the comet's own mass as propellant. This acceleration didn't fit any known comet behavior. For the first time, the data hinted at a maneuver, with a sudden flare and course change locked together in the logs. And if you put that in plain English, if that heartbeat we're seeing is somehow steering this colossal snowball, the line between mere chemistry and outright biology blurs so fast it practically vanishes. It's a course change that hints at purpose, a flare that signals power, and it makes you wonder what kind of object changes course mid-flight. Now, before we get too carried away with the "it's alive" narrative, let's bring it back to Earth, or at least to the limitations of our current technology. Webb's mirrors are absolutely supreme at infrared spectra, giving us incredible insights into chemical compositions and temperatures. But here's the reality check. Life detection, true, undeniable life detection, needs several lines of evidence. Ideally, we'd want to see amino acid ratios, isotopic handedness, or dare I say it, direct microscopy. We need to see the cells, analyze their building blocks. Right now, this enigmatic comet is 8 astronomical units out, meaning it's 8 times the distance between Earth and the Sun. Even our mighty Hubble can't resolve surface features at that distance. The plume we're seeing is a smeared cocktail of gas and dust. JWST reads the bulk, the overall signature, not single molecules, not individual structures. Until a probe can rendezvous, and let's be clear, no agency has funded such a mission yet, we're left with indirect clues. Think of it like a doctor trying to diagnose a patient by listening to a cough from across a football stadium. The cough is real. Pneumonia is certainly possible, but infection versus allergy, that needs a much closer inspection, doesn't it? Now, let's address the elephant in the room, the headline that loves to scream, "It's moving toward us." In reality, the closest approach for 3I Atlas will be 1.2 times the Earth-Sun distance. That's safe by cosmic standards, folks, so no need to build your bunkers just yet. But here's why its chemical behavior matters regardless of any impact risk. If 3I Atlas is a template for interstellar objects, and remember, it's only the third we've ever confirmed, and if, say, a third of them carry this kind of self-sustaining anomalous chemistry, then every few years, a frozen petri dish could be coasting right through our neighborhood. Statistically, over the age of the Sun, that translates to billions of chances to seed Earth-like worlds throughout the galaxy. The discovery that comets can host autocatalytic reactions, that they can be these dynamic, self-driving chemical factories, would fundamentally rewrite astrobiology textbooks, even if no actual cells are involved. It suggests that life's ingredients, perhaps even the precursors to life, may be cooking in deep space long before planets even form, carried across the cosmos, ready to spark something new. So how close are we to getting some real answers, to lifting this cosmic veil? The next crucial window is fast approaching, December 2025, when the comet passes perihelion, its closest point to the Sun, and activity is expected to peak. Our trusty JWST has already been allocated a second intense stare. The Very Large Telescope in Chile will add optical polarimetry to the mix, peering into the light to understand the physical properties of the dust and gas. And the brand new Extremely Large Telescope, also in Chile, will attempt to resolve the jet sources with unprecedented detail. What are we looking for? If the rotation quickens, or if those puzzling nickel-to-iron ratios flip in a particular way, the self-sustaining hypothesis, the idea of an internal engine, gains even more credibility. Meanwhile, our intrepid lab teams are racing against the clock, trying to grow cryogenic microbes on CO2 cyanide media under vacuum conditions. If any strain, any Earth microbe can reproduce at a bone-chilling -220 degrees Celsius, well, the biology camp gains a massive amount of credibility. And then there's the audacious yet thrilling possibility. A private rocket startup has floated a fast flyby CubeSat proposal. Funding is uncertain, the timeline is impossibly tight, but if launched by March 2026, it could skim the coma at 20 kilometers per second and return precious dust samples to Earth by 2030. Until then, my friends, the question mark stands tall and proud.
This, my friends, is where science truly becomes civic, where we all have a role to play. Every wild claim needs scrutiny, absolutely, but dismissing curiosity, shutting down the what-if questions, is just as dangerous. We need to keep one foot firmly planted on evidence and one eye wide open to wonder. If 3I Atlas proves that comets can brew lifelike chemistry, that they can be these dynamic, self-driving chemical factories, then the Copernican principle, the idea that Earth isn't special, suggests the galaxy is absolutely teeming with it. It changes everything. And if this anomaly, this incredible mystery, simply fizzles out, if it turns out to be an exotic but understandable natural phenomenon, we still gain a new class of comet reactions, valuable data for protecting Earth from future rocks and expanding our understanding of cosmic chemistry. Either way, you, by staying informed, by asking questions, by engaging with this incredible journey, you win. So, 3I Atlas isn't an alien invasion fleet, thank goodness, but it may be something just as transformative, just as profound. A natural experiment in self-driving chemistry drifting right past our cosmic doorstep. JWST, with its incredible vision, opened the door to this mystery. Now the clock ticks on follow-up data, on closer looks, on more questions. Whether that intriguing heartbeat fades into a natural explanation or quickens into something truly unprecedented, one truth remains. Our next cosmic neighbor might not ask permission to rewrite the rules of biology. So keep watching the skies, my friends, because the universe is already watching back, and it's always ready to surprise us.